Okay, record and then I'll put it in Facebook. Answer the question. And one of you has been asking this question, so I'm going to try to answer for you now. Okay, this one is about momentum in 2 dimensions. A ball of mass 0.2 kilogram traveling in the x direction. That's your x direction. Have a speed, as the speed is given. Collide with a ball of, that is the mass, 0.3 kilogram traveling in the y direction. That's the speed. They collide here. The two balls stick together after collision, traveling at an angle theta. Right? So that is the final momentum. They travel in this direction. What's the value of theta, this angle? Okay, remember, we are going to work with momentum. Momentum. T is momentum, not velocity. And it's a vector. Right? So the momentum P1. P1 is this one. This one. P1. Calculate momentum, not velocity, momentum. Mass times velocity. And after that, P2. Mass times the velocity. Right? Momentum. Then we are using conservation of momentum. And then this is, remember, it's a vector equation, this one. Vector equation. So vector equation, we can treat this as a vector. Normally we use forces there. So this is a resultant. These are the two components. So let's draw P1. Right? That is your P1. Right? Draw P1. Right? That's your P1 going vertically in the y direction downwards. And P2. That's your P1. And this is your P2. Horizontal direction in the x direction. That's your value. Then that's where you start, that's where you stop. So that's the resultant momentum. No? That's the P there. Right? The resultant momentum or the final momentum. That's your P. Then look at the angle. That angle is theta. That's your x direction. That's angle theta. Right? This alternate angle. These two are parallel line. This is also theta. And to solve for the angle, we just take the tangent. No? Tangent of this angle. Stop me if you want to ask question. Right? 0.
Hey, sir, I didn't know this time this question can use vector triangle.
Can. These are vector. You are supposed to use vector.
Oh.
You're supposed to use vector. No other way.
Oh, okay.
Use we have learned vectors. So we usually learn with forces. Now we are applying it to momentum. So 0.2 to 0.1, then you get that one. Find your answer. C. Okay with that?
Okay.
Any comment? You can use component method. Usually exam will ask you to use component method. Same thing. You have to find your P1 and you have to find your P2. Same thing. And that's your P. Okay. Conservation of momentum, you must remember. Right? Vector, this is a vector equation. And then you use component, then you must resolve in the y direction. That means all this must be in the y direction. Okay, resolving the y direction, you have your initial one, this one, P1, 0.12. And then this one don't have y direction. That's why we don't add them up. Or P2, P1. And the resultant of this one, P, final one in the y direction is your P sine theta, which is this one. Then resolving in the, sorry, this one should be x direction. Let me just correct the mistake. Okay, should be in the x direction. Resolving the x direction, this is the only one in the x direction. Initial, final one is just your P cos theta. These two must be the same. Resultant. And 2 divided by 1, 2 divided by 1. So you come back to the same thing as previously. Tangent theta, sine theta or cos theta is tangent theta. And Sorry, did I do something wrong? Sorry. 1 divided by 2, not 2 divided by 1. Sorry. 1 divided by 2. Yeah, maybe a bit more, take more steps if you use component method. Okay. Equation 1 divided by equation 2. This one divided by that. P and P cancel off. Sine theta or cos theta is a tangent theta. And then you get your value. Okay, any comment? Anything not clear?
So either I can choose use vector triangle or
Yes,
component.
either way, whichever you prefer. Usually in paper 2, they will ask you the component method. It doesn't mean that you are stuck with that. And then you just answer their question what they want.
Okay.
If no question, we go to the next question. This one, right? Doesn't tell you where it say a particle of mass m, charge q, enters a uniform electric field. So since it's a positive charge, the electric field must be vertically downwards. So, right? The speed is v. Initially, the particle is traveling at right angle to the electric field. So as I said, the field is vertically downwards there. During its movement through the field, the particle is deflected through a distance d, as shown. Right? So this is like projectile. You throw the object horizontally. Right? You throw it horizontally, that's how it moves. A second particle of mass 2m, charge the same, speed the same, enters the field along the same path. What is the distance through which the particle is deflected in the electric field? Right? You want to find this one, the new d in terms of this small d. So always get the equation. No? Right? Consider vertical motion. Right? Vertical motion. Remember, this v is the horizontal motion, horizontal velocity. Vertically is 0. S is your d, or d is your s. Then your acceleration is force divided by mass. Force is E times Q, electric field strength times your charge, divided by M. T, right? We are interested in the time. And since the horizontal velocity is constant, T is the same for both situations. Right? Horizontally, it will travel the same distance during the same time. So vertically, our S equals to UT plus half AP squared. U equals to 0. So our S in this case is D. And then our half is our half. U is 0. That's our half. And then A, that's our A, E, Q over M. And then there's your T squared there. Right? That's the original one. Now we change it to 2M. Same charge, same velocity. So new deflection, right? New deflection, E is still the same, U is still the same, time is still the same. Right? That 2 is still there, the 2 is still there. But that M, I replace it with 2M. 2M there. So that equation is still D. Right? That equation there is still D. So it's half D. Answer B. Anyone? Any comment? Anything you're not clear, you want me to explain further? Anyone? If not, that's the end of our session. Any question you want to ask or anything you want to talk about, you can ask. We still got plenty of time. Anyone? Any question? If no question, you want to go, can go, no problem. I will stop the video in a while if you got no question. You got question, I will answer you.
So
Sir, we post it to Facebook, right?
Say again.
You post it in Facebook, right?
Yes, I'll post it in Facebook.
All right, thank you, sir.
Video, they allow me. I don't know why PowerPoint I cannot post it now.
So on 18 resume class, right? As normal.
I think so far should be no problem with me though. But I think your other teachers will be too busy though. marking paper, conducting a semester exam. But for me, looks I'm quite free lah next week. So I will carry on unless they ask me to invigilate, then I have to cancel the class. So as far as I know, I'm quite free.
So the trial exam for those people
Online. Still online.
online, right?
Online.
Still online.
The new intake students also don't like it. I'm happy about it, but no choice. You have to give them a semester exam because you don't know how long the MCO is going to be on.
Oh, okay.
You can see next month, I think, is it 9 or 10 after that? We don't know. Anything else you all want to ask? If not, you want to go, can go, no problem with me. I will
No,
close
sir.
it.
Thank you, sir.
Any
Thank you,
question?
sir.
Okay, bye-bye.
Thank you, sir.
Okay, bye-bye.